Today we are going to discuss about graph traversals using depth first search. Graphs can be traversed in two different ways. First is depth first search. The second method is breadth first search. Now I'm trying to explain you the depth first search method, in which assume that there is a graph, it is having some 8 vertices and some edges are connected to it. In a graph traversal, there is no particular start vertex. You can select any vertex as your start vertex. From any vertex, you have to traverse all the vertices. Traversal is nothing but visiting all the nodes or vertices. Here we say vertices. In the graph, we need to visit all the vertices. Let us assume that we are starting at vertex V1. Start with V1, vertex V1. Visit V1. Visit V1. V1 is visited. Then the adjacent vertices of V1 are adjacent vertices. What are adjacent vertices? See here, V1 is adjacent to V2, V1 is adjacent to V8, V1 is adjacent to V3, V2, V8, V3 are adjacent. V1 is visited and there are three adjacent vertices. Instead of visiting three vertices, we visit only one. Let us assume that we visit the first one. Is V2 visited? No, V2 is not visited. So try to visit V2. So visit V2. Then find the adjacent vertices of V2, unvisited adjacent vertices. Adjacent of V2 are, what are adjacent of V2? V1, V4, V5. V4, V5. V1 is visited, so no need to visit again. Then unvisited vertices are V4 and V5. Visit one, either V4 or V5. For example, let us assume that we are visiting V4. Visit V4. Again find adjacent vertices of V4. What are adjacent vertices of V4? They are adjacent vertices of V4 are V2, V8. V2 is already visited. V2 is already visited. So the only vertex that is unvisited is V8. So visit V8. Visit V8. Then find out adjacent vertices of V8. Adjacent vertices of V8 are, what are adjacent vertices of V8? V4, V5, V1, V4, V5, V1, then V6, V7. V6, V7, in which some vertices are already visited. Is V4 visited? Yes, V4 is visited. Is V5 visited? No. Is V1 visited? Yes. Is V6 visited? No. Is V7 visited? No. So there are three unvisited vertices. Out of these three vertices, we visit one vertex. Normally, assume that we are visiting V5. Visit V5. Again, find adjacent vertices of V5. Adjacent vertices are V5 or, what are adjacent vertices? V2, V8. V2, V8. V2 is already visited, V8 is already visited. So we are in some deadlock. So all the vertices that are adjacent to V5 are already visited. So we go to the previous stage. Go to previous stage, that is backtracking. Backtrack. So go to previous stage. What is the previous stage? It is V8. V8. It is the previous stage, V8. Adjacent of V8 are adjacent of V8. What are adjacent of V8? V4, V5, V5, V1, V6, V7. V4 is already visited, V5 is visited, V1 is visited. Then remaining are V6 and V7. We normally visit first one, hey, V6. Visit V6. Visit V6. Then find adjacent vertices of V6. Adjacent of V6 or, what are adjacent of V6? V3 and V8. V3, and V8. V8 is already visited. What are the other vertices? V3. So visit V3. Visit V3. What are adjacent vertices of V3? Find vertices of adjacent to V3 are V1, V6, V7. V1, V6, V7. V1 is already visited. V6 is also already visited. The only vertex that is not visited is V7. So select V7 and visit it. Visit V7. Is there any other vertex adjacent to V7? Adjacent to V7. What are adjacent to V7? V3, V8. V3, V8. V3 is already visited. V8 is also already visited. So we came to some dead end. Again, go back. Go to previous stage. What is the previous stage? V3. Are all vertices visited? Now all vertices are visited. Like that, we go back because it is a recursion. Once you go to some stage and again you will come back to the original stage or initiating stage using recursive function calls. Now using this, first you have visited V1, then V2, V4, V8, V5, V6, V3, V7. This is the sequence V1, V2, V4, V8, V5, V6, V3, V7. So this is the order. First visited is V1, then V2, then V4, then V8, then V5. As you came to some dead end, it backtracks. It goes to again V8. Don't count this V8 two times. It only one time. Next next vertex we visit is V6, then V3, then V7. Again you go back because it is a recursive function, go back and checks whether any other vertices are unvisited. If it is there, again that node, particular node will be visited. Otherwise it go back and again it goes to the start vertex, so that all the vertices here are visited: v1, v2, v3, v4, v5, v6, v7, v8. All the 8 vertices are visited here. So this is the order where using depth first search, if you select V1 as the start vertex. Let me explain the algorithm to traverse a graph using depth first search method. Depth first search algorithm, DFS. DFS vertex V. Vertex V is the parameter here, formal parameter. We pass start vertex normally. Start vertex. Then in this, initially whatever the vertex we start, we visit that and we find adjacent vertices of V for each W adjacent to V. What is V? Maybe vertex. If not visited, again call DFS function. It is a recursive function. Recursive function. If you use recursive function, it automatically uses stack. It calls so many functions. The previous one is placed in stack. Now use the same example. This is the graph where we wanted to traverse in depth first search. Assume that V1 is the start vertex. Start vertex. So DFS V1. We call DFS V1. See, if you execute these instructions, vertex V is V1. V1 is our start vertex. Visit V. That is visit V1. Visit V1. Then we are finding adjacent vertices. What are adjacent vertices? Adjacent vertices are V1 adjacent are V2, V8, V3. V2, V8, V3. If not visited, yes, these three are not visited, then call DFS function. So you may call 3 times, but now we call each time one V2. DFS, for example, we call V8, V2 first. DFS V2. There are 3 vertices, we call V2. Whenever you call V2, again the DFS function will be repeated. Vertex V may be now V2. Visited V2 is true. Visit, mark it, visited. Visit V2. V2 is visited. Again find adjacent of V2. Adjacent of V2. Adjacent of V2 are V1, V4, V5. V1 is already visited because here we are considering only unvisited vertices. So V1 is already visited. We have only two adjacent vertices here, V4 and V5. We call DFS function for both. For initially, we call the first one, right? At a time, we may not call both. V4, DFS V4. What happens if you call DFS function again? All these instructions will be executed. Visit, visit V4, visit V4. Then it finds unvisited vertices. Take the adjacent vertices. Adjacent vertices of V4. V4 adjacent are V2 and V8. V2 and V8. V2 is already visited, so there is only one adjacent vertex, V8. So call DFS function, DFS V8. Whenever you call DFS function, automatically it will be visited. Visit V8. Visit V8. What are adjacent of V8? V4, V5, V1, V6, V7. Unvisited adjacent vertices. V4 is already visited. V1 is already visited. The remaining unvisited vertices are V5, V6, V7. We select first one normally and we call DFS function DFS V5. Whenever you call DFS function, it automatically visits. Visit, visit V5. What are adjacent vertices? Adjacent vertices of V5 are V2, V8. V2 is already visited. V8 is already visited. There are no adjacent vertices, unvisited vertices or adjacent vertices now. So it has to backtracking. It has to go back to one step. Backtracking. Backtracking. It goes one step back. Again, it goes back V8. Right? At V8, what are the adjacent vertices? It goes to the previous stage. So here already V5 is already visited. The remaining nodes are V6 and V7. So in this V6 and V7, you may select V6 as for your next function call V6, DFS V6, visit V6, visit V6. Then what are adjacent vertices? Adjacent vertices of V6. V6 adjacent are V8 and V3. V8 and V3. V8 is already visited. So we may select V3. DFS V3. DFS V3. So whenever you call DFS of a particular vertex, automatically it visits. Visit V3. Then it finds adjacent vertices. Adjacent of V3. What are adjacent of V3? V1, V6, and V7. We need to find unvisited vertices. V1 is visited already, V6 already visited. So unvisited vertex is V7. We call DFS function DFS V7, DFS V7. So whenever you call DFS V7, it visits visit V7. Then it finds adjacent vertices. Adjacent of V7 are V3 and V8. V3 already visited, V8 is already visited. So it has to go backtracking. Backtracking. It goes to previous stage. This is the previous stage. The only V7 is marked as unvisited, but here already V7 is also visited. It goes to previous stage. V3 visited. It goes to the first stage, right? Like this, it goes to again the first stage. The sequence we have got in here is V1, V1, then V2, then V4, then V8, then V5, then V6, then V3, then V7. This is the sequence where you have generated with depth first search algorithm. That is You are visiting V1, then V2, then V4, then V8, then V5. It goes back, then V6, then V3, then V7. This is the order where you have traversed the graph, right? V1, V2, V4, V8, V5, V6, V3, V7. Traversal in depth first search. Traversal is nothing but visiting all the nodes. Visiting all the nodes. We have visited all the nodes. See here, there are 8 vertices already. All 8 vertices are visited. So 8 vertices are there. 8 vertices have been visited. So we have visited the vertices of a particular graph using depth first search, where depth first search algorithm uses recursive function. If it is a recursive function, it uses stack. So you can use this as an application of stack also. Thank you.